these angles is going to be on the center of the circle. So just to review this relationship, because you might use this in a couple questions today. Okay, if your vertex of an angle is in the center of the circle, that's called a central angle. And a central angle and the arc are actually the same. There's not a 2-to-1 relationship. Guys, let's put the computers away, please. Thank you. All right, so if this is 145 here, this is the angle. I'm just going to kind of highlight that just a little bit. The arc that it runs into, if it's a central angle, is exactly the same. So if that guy's 145, then, and I'm going to go back and answer the questions here in a second, but this would also be 145. So if the vertex is on the center of the circle, they're going to have exactly the same arc. So I could also do that like right here with this 86. That arc is from T to S. So the angle, the central angle is 86. The arc would be exactly the same. So from S to T, the measure of that arc would be 86 degrees. Now, what I can do, let me find these other angles or these other arcs, however you want to think about it in this diagram. If you have a diameter, which we do here from S to Q, it goes right through the center of the circle and it goes all the way across. That splits the circle into 2 equal pieces. Does anybody remember what half of a circle adds up to in terms of the degrees? Like if I just do half the circle, what does it add up to? 180. All right, so here's all I would do. This angle's 145, this arc's 145. This arc and this angle have to add up with that to be 180. So I would just grab my calculator, do 180 minus 145, should be 35. So this little angle in here is 35. Also, the corresponding arc right there from S to R would be exactly the same, 35. I'm just trying to write some information on the picture and then I'll go back and answer those questions. So same argument, if I just look at that, there's my diameter. This half of the circle right here, I have 86 degrees of it so far. This angle and this arc would add up with that to be 180. So all I got to do, grab your calculator or do it in your head if you want. 180 minus 86. The left over there is 94. So 2 things I can get here. This angle is 94. Center of the angle is, or the vertex of the angle is on the center of the circle. So then the lovely arc is exactly the same. So then I'm just going to go through and see if I can answer these questions. So SR, the arc, is just right there. We labeled that with the 35. STQ. All right, so STQ, start at S, go toward T, end up at Q. That actually just goes half the circle. Or you could take the 86 and 94, add them together, but SQ should just be 180, or STQ, sorry, should be 180. I'm going to grab a different highlighter. Okay, so RTS. Now my instinct is to go RT, but to get to S, I would have to go more than once around the circle. So I actually would go counterclockwise here. So you would start at R. I'm going to try it, like just go around the outside. R over to T, all the way back to stop at S. So it would be all of the circle except that little piece that I have colored kind of in pink. So there's a couple ways you could do this. Add the arcs together as you go around. So we could do 145, 94, and 86. Or if you want, you know all the way around the circle's 360. So just do 360 minus that little piece it didn't include, which was 35. Both of those should give you the same answer. That would be 325. And then TQ, that's the one I originally just kind of did in purple right there. That was just 94, so I'm just taking that right out of the diagram. Does anybody have any question about central angle and arc? The central angle, so the vertex is on the center, and the arc it goes into is exactly the same measure. What we're going to do today is going to be half the measure because the vertex of the angle is going to be on the circle. So we have just a little review. 2 definitions. A tangent line, in the picture here underneath here, it's a line that just like brushes by the circle and just touches it in one point. So in this picture here, that's point A. They call that the point of tangency. So that line would just brush by that circle and it just touches in point A. Now a chord, we also talked about a chord. Chord in the picture here is from B to A. A chord is just a line segment where both endpoints are on the circle. So A is actually the point of tangency, and it's the endpoint of the chord. B is the other endpoint of the chord. So there's two angles that are created there, and there's two what we call intercepted arcs. So if I look at angle 1, just for a second, I'm going to highlight angle 1, the intercepted arc. And I know it's kind of weird. It's a little different than what we were looking at on Thursday, because we had the angle going through the circle, whereas here, because I've got a tangent line, it's like it goes outside the circle. So angle 1 would go all the way here. So it would be the angle that it makes with that tangent line. That would be angle 1. Now, the intercepted arc there goes from B to A, and this is always true. If the vertex of your angle is on the circle, which A would be the vertex of that angle, the intercepted arc, you just cut that in half to get the angle measure. If you know the angle measure, you multiply it by 2 to get the arc. So I'm going to write two things here. Angle 1 is going to be half of arc BA. So if you know the arc, you can cut it in half and get the angle. And the other relationship, if I do 2 times angle 1, that would give me the measure of the arc from B to A. So it depends on which one you know. If you know the arc, cut it in half to get the angle. If you know the angle, you just multiply it by 2 to get the arc. The other angle that creates an intercepted arc here is angle 2. And the intercepted arc from angle 2 goes all the way around here. So again, it's the point of tangency, that little A, and then the end of the chord, which is B. But if I'm talking about angle 2, it's this little part I highlighted in purple. So kind of the same relationship here. I'm going to say angle 2 would be half of that arc. It goes from A to C to B. Or if you know the angle, you can multiply the angle by 2, and that'll give you the measure of that arc. Now, see if this makes sense to you guys. All the way around the circle is 360, right? If I just have a plain straight line, what does a straight line add up to? 180, right? So 180 is exactly half of the circle. So here's how this is. These two angles would have to add up to 180 because they make a straight line, but the arcs have to add up to 360 because it goes all the way around the circle. That's why the arcs are going to be twice the angle, because twice 180 will give you all the way around the circle, which is the 360. I just made that sound like way more complicated than these problems are. I promise this is not hard. So I'm going to grab my highlighter to kind of show you what we've got in the picture. Here is the tangent line. So it just brushes by this circle and it touches it. They labeled it here in this diagram with point B. Now the deal with point B is also an endpoint of a chord. So a chord just connects 2 points on the circle with a line segment. So A and B are both on the circle there. So I've got a tangent and then I've got a chord. Where they have angle 1, this would be your intercepted arc. It starts at that point of tangency and it goes all the way around to where that chord stops. So if the vertex of angle 1 is where the B is at, if it's on the circle, all you got to do is cut the arc in half. So it says the arc is 150. So angle 1, all we're going to do, just take 150, divide by 2, or multiply by a half, however you want to do that. But that's just going to give you 75. So angle 1 there is exactly half the measure of that intercepted arc. So it's just going to be 75 degrees. That's all you have to do. If I have this one next to it, here's my tangent line. So it's just going to brush by the circle and just touch it in point P. Point P is also an endpoint for this chord. So the chord goes from P to R. And if you guys see where the angle is inside here. So what I want to do for my intercepted arc here, I want to start at P, and then I'm just going to go all the way around to where that chord stops at point R. So that whole arc right there, and that's what they're going to ask for in the directions. PSR would be this whole arc. So if you know the angle, so the angle's 130, if I know the angle, I'm going to multiply that by 2. So that's going to give me 260 degrees. So like out here, this would be 260, that whole thing that I have in yellow. here, I'll just show you this while I'm doing the problem, right? This is a straight line. The tangent line is a straight line. So if that whole angle is 130, I could also have this angle right here would be 50. Those two have to add up to 180. And I could also have that arc. So the arc goes, for this one, goes from P to R. If that angle's 50, you just multiply that by 2. That's 100. And if you think about that, if I take 100 and add 260 to that, that's going to be 360. So that's the relationship. That line is 180, all the way around the circle is 360. So if you know the angle, multiply it by 2, that'll give you the arc. If you know the arc, you cut it in half to get the angle. Now, there's a couple ways to do these problems, but it's a little bit trickier. Same kind of a concept. Here is my lovely tangent line here. And they don't mark the point of tangency, but I'm just going to put a little dot in my picture there. There'd be the point of tangency. And that angle is being formed with this chord. That's just the line segment that's going through the circle. The endpoints of that are on the circle. And the intercepted arc would start at the point of tangency and then go around until you get to the end of the chord. All right, now that gives me that arc measure is 260. If that arc measure is 260, all I have to do to get the angle is just cut that in half. So I know the angle right here, take 260, divide by 2, that's 130. All right, so this angle is 130 degrees. To actually answer the question, we're just going to set it equal to that little expression they give you in the diagram. So that angle, it says, is 8a plus 10. And it's just 2 steps to get your variable there. Just subtract 10 real quick. I'm going to get 120 equals 8 times a. And then I'm just going to grab my calculator. We're going to divide by 8 here. And I'm pretty sure that's a nice number. It's 15. So a is just 15. But the key there is that the arc, if you know the arc, just cut it in half and then you can set up your equation. So 15 is going to be the value of my variable there. The last one is probably the trickiest. So there's actually 2 ways you can do this problem, but here's your tangent line. And it's just going to brush by the circle and just touch it at point B. Point B is also an endpoint of a chord, and that chord goes across the circle to point D. So chord, it's just a line segment that goes through the circle. Endpoints are both on the circle. To get an intercepted arc here, all I'm going to do is take and go from my point of tangency, which is B, all the way around here to point D, where the chord kind of stops it. Now, I don't have any numbers here. Like on the last one, I had 260. This one, I have that the arc is 9x plus 20, and I have the angle is 5x. Anybody know how you could maybe set up an equation to figure out what x was here? There's 2 ways you could do it. I don't have any angle measures. How could I set up an equation? I know here's the angle and here's the intercepted arc. Like, what could I do with those 2 expressions to set up an equation there? Any idea? If I told you the angle was 50, what would you set this equal to? If I just told you this angle, it's not, but if I told you this angle was 50, what would you set it equal to? If I told you the arc was 50, you'd set that equal to 25, right? Okay, all we have to do, the angle, if I do 2 times the angle, it's going to equal the intercepted arc. The other thing you could do half the arc equals the angle, but I think that's a little bit harder. So if I just take it like this, just going to multiply it by 2. My angle, they give me 5x, and then my arc, they give me 9x plus 20. So it's just weird because I don't have an actual number here, but we can just use the expressions. So if I take 2 times my angle, which is the 5x, it has to be equal to the arc. This, you can always multiply this just 10x. And then the arc was 9x plus 20, but it's got that 2-to-1 relationship. So I'm just taking the angle, multiplying it by 2. And this is super fast to solve. You're just going to subtract 9x. And in this case, that's really nice for us because 10x minus 9x is just 1x. So x is 20. If I know that, we can just plug it right back in and figure out these angle measures. So 5 times 20, this would be 100. And then this should just be automatically. It should be 200. It should be twice that. But if you wanted to check, 9 times 20 is 180 plus 20 would give me the 200. But it should be that relationship there. If we had to find the other angles, I'm just going to mark them in the picture real quick. I know they don't ask you for them. But if this is 100, this would be 80. This angle like DB and then the rest of that lovely tangent line. And let me grab a different color here. The intercepted arc for that 80 would be from there to there, but it's just the rest of the circle. Just multiply that by 2. That would be 160. I know it doesn't ask you for that, but you can literally find the whole thing if you know that one angle and that one arc from the beginning of the problem. Is anybody having a question? Okay, now I got some really complicated diagrams on the back that have a lot of stuff going. So the reason I had you guys at the beginning kind of review the central angle, and I know this is a lot. Okay, there's a lot going on in this picture. So it says RS, so right here, and TU. They go right through the center, and it says those are diameters of this circle. And it says RB is tangent to the circle. So this is kind of like what we've been doing. This guy just brushes by this circle and just touches it in point R. So this is a tangent. This is kind of a review question. So it kind of has some of what we did today, but it also has some kind of review with it as well. So I'm just going to draw on the diagram and then we can work backwards and answer the questions. That's probably the easiest way to do this. Just try and write as much information as I can. So first thing I would show you, this is a diameter and this is a diameter, right? What I would also notice, do you guys see where the 126 is? So that's actually very beginning of class today. If you remember, we do a central angle. If you have a central angle, that runs into, I'm just going to color it the exact same color, this arc. So if that's 126, this arc that goes from R to U would be exactly the same. So that's going, I'm marking that from R to U is 126. The central angle and the arc are the same. And if you guys remember way back beginning of geometry, do you guys see this kind of this X shape here? These are vertical angles. So if this is 126, this angle like the TAS, that would also be 126, but that also will give us this arc right here from T to S, because that central angle and the arc are the same. So this is just a little bit of review. TS, I'm going to write this so you guys can, I'm going to garbage this diagram up a bunch, I know that. Okay, now here's what I can also use. I'm going to kind of cover up part of this diagram. If that's a diameter, right, from R to S, this much of it is 126. The rest of it makes the other half of the circle. So the 126 and this angle right here, or sorry, this arc right here would have to add up to 180 because it goes exactly halfway across the circle. So I'm going to subtract 126 there, get an angle measure. So 54 is this arc. It is also this central angle. The arc and the central angle are exactly the same. All right. Now on the other side, I'm going to cover this up real quick. I can make literally the same argument right here. So this is the diameter. This much of it is 126. And this little piece from R to T would be the rest of the half of the circle. So that's going to also be 54. That makes this central angle 54. Okay, now let me go over to the questions and see if I've got everything I need to answer some of these questions. Okay, RT, I got that labeled. That was 54. BRT. Now, I don't have this labeled, but we can do it. So this is actually what we talked about today. So the angle, I'm going to kind of try and draw a different color. BR, here's T. This is what we talked about today. That's made by a tangent and a chord. So that intercepts this little bitty arc right here that's 54. If the vertex is on the circle, you're going to take the arc that it intercepts, which is 54, and divide it by 2. So that angle would be 27 degrees. We're just cutting that arc that it runs into in half. I'm not going to draw that. Well, maybe let me see if I can fit it in here. So this angle would be 24 degrees. The arc is 54. I don't know why I just put 24. 27 is what I meant. 27. The arc is 54. The angle will be half of that. T to S, we got that labeled in the picture. That's 126. TRS. Okay, let me see if I can highlight this. Here's T to R to S. So this is a little bit of review from Thursday. This is a chord and another chord that are forming that angle. They run into this arc, which is 126. So if the vertex is on the circle, which R's on the circle there, you're just going to cut that arc in half. So I'm going to take 126 and cut it in half. So that should be 63, which would be in here. This is not a central angle, so it's not the same. If you have an inscribed angle, it's inside the circle, the vertex is on the circle, you cut the arc in half. All right, RUS is this arc, and it's just exactly half the circle, so R to U to S is just 180. And where is URB? Let me see if I have a different color. Okay. Here is U to R to B. This is actually also what we talked about today. Okay, so here's the chord, and that R to B is part of that tangent line. The intercepted arc, let me see if I can kind of color around here, would go from R, and then it would go all the way around here till I got to U. So here's URB. That intercepted arc would go all the way around there. Okay, now I've got the 54, the 126, and the 54. Those are all those arcs all around there. So I'm just going to add that up. 54, 126, 54. So all the way there, that's 234. If the vertex is on the circle, we're just going to take that, cut that in half. So I'm going to take 234, divide that by 2. And so that angle is 117. And I don't, feel free, if any of these diagrams, draw on them all you want with highlighters and stuff. It helps me see it a little bit better. If the vertex is in the center, the arc is the same. If the vertex is on the circle, you cut the arc in half to get the angle. Okay, I've got one more. This one isn't quite as many problems here. All right, so I've got a tangent line again. Here's my tangent line from J to K. So we're just going to brush by the circle and touch it in this one spot. And my first question is to find the arc from Q to L. All right, how many degrees is this? Can you guys tell? You don't need the 35 or anything. How many degrees would Q to L be? 180. It's exactly, see, there's your diameter. It goes through the center, exactly half the circle. So this is 180. Okay, now, this is going to build on this. So I want to find the measure of the angle from L to J to Q, which would intercept that arc we just found the measure of. So if my vertex, which is J, is on the circle, anybody know what that angle would measure? 90, because you ran into the diameter, right? That's just 90. Now, totally up to you, but this is what I would do. Do you guys see how there's, like right here, there's a little triangle inside here? I would just find Y by knowing that the triangle adds up to 180 on the inside for the angles. So I know this guy right here is 90. So I'm just going to do 180 minus 90 minus 35. The leftover has to be angle Y, which is just 55 degrees. And maybe I should not have done that with that color like that. This is 55 though, to help us. So Q to J is an arc, and I'm going to try to get an angle around that that runs into that to do that, for that particular problem, let me do a different color. Do I have a different color? Yes, I do. All right, so where angle Y is at, if you guys see that, is 55 degrees. That 55 here is that inscribed angle intercepts that arc, right? So here's angle where the L's at. That's 55 degrees. That runs into QJ. If the vertex is on the circle, and this is, sorry, let me make this so you can see it better. This is 55 degrees. To get the arc, I could just multiply that by 2. So if I have the angle, just multiply it by 2. I don't know why I wrote the same exact thing. It'd be 110. All right. Now, I know this is 180. I know this is 110. J to L is right in here. But that's just the rest of the circle. So I already know this is 180, this is 110, it's just the rest of the circle. So I'm going to take 360 minus 180 minus 110. The leftover has to be 70. So right in here, this will be a 70-degree arc. And then the last thing is to find X. And I have really garbaged this diagram up. Okay, here's X. I'm just going to kind of highlight that just a little bit with my pen. Now, that intercepts this 70-degree arc. I know it's like a garbaged up diagram at this point, but if the arc is 70, the vertex is on the circle where the X is at, which that is, you just cut that in half. So 70 divided by 2, where X is at, would be a 35-degree angle. So if you have the arc, you're going to cut it in half if the vertex of the angle is on the circle. If you have the angle, you multiply it by 2 to get the arc. If the center of the angle is on the center of the circle, the arc and the angle will be the same. Is anybody having a question? Okay. The homework is super similar to this. So if you guys want to grab